Okay, so the next module is about chemical equations. So the first thing to learn about in chemical equations is that of balancing equations. The balancing equations essentially is about the different elements and atoms that are present in a chemical reaction. For example, C3H8 plus 5O2. So now we know when we combine these two reactants, it will form some products. In this case, we know that there will be two products, and we can kind of identify and we can verify the validity of the products based on the information we'll learn now. So the products are 3CO2 plus 4H2O. So to verify this, we can ensure that the number of atoms on both sides are the same. This can be shown through this. For example, if we're looking at the hydrogen, here we have H2 multiplied by 4, so 2 times 4 is 8 on the product side, and we found that there is 8 hydrogens on the reactant side. Then regarding oxygen, we have 2 here, and then multiplied by 3, so 6, and then 1 here multiplied by 4, so 10. And then we have 2 here, so 10 on the product side, and then 10 on the reactant side, 5 times 2. And then lastly, to ensure that it's all the same, we would have 3 carbons on both sides, and you can see that is true here and here. Another important thing to consider is state symbols. State symbols are basically a way of indicating the state or the type of matter uh, the compound is in. For example, there are 4 different types. There's S, L, G, and AQ. S signifies solid, whether the, the substance is solid, and then L is liquid, G is gas, and AQ signifies aqueous. Aqueous shows or it illustrates and it indicates that the element and the compound has been dissolved in water. Okay, so the next thing we'll look at is conservation of charge. So just like we see in balancing equations, the number of each atom is the same on both sides. Then um, the charge, to further verify, the charge on the products and the reactants must be equal as well. And the charge on the product should be 0, and the charge on the reactant should also be 0. So an example of this would be Cr2O7. I'll be writing in the charges later. Fe14H. And the product is 2Cr plus 7H2O plus Fe3. Okay. So in redox chemistry, we find that based on the oxidation states of each element, they'll have their own redox state. This kind of is based on the amount of electrons they have in their valence shell, signifying how many electrons they'll either want to take in or remove in order to complete their outer shell. So Cr, and then on the whole, Cr2O7 has a charge of 2 minus, and then Fe has a charge of 2 plus, whereas 14H has a charge of plus, then 2Cr has a charge of 3 plus, 7H2O has no charge, and Fe3 plus has a charge of 3 plus as well. Or sorry, Fe3 plus is 3 plus. So then when you add up these charges together, we'll find that we'll have to now add on some charges and add on some other moles to ensure this equation is balanced. So we see here that the overall charge on the right hand side is +6, whereas the overall charge on the left hand side is +1. So to make that completely correct, we would have to make it 6 Fe and 6 Fe3. Now when you add up everything, this would become 11, an overall charge of 11, and this one would become an overall charge of 11 as well. And lastly, there's also a conservation of mass. So for example, Fe plus, I'll include state symbols for this, Fe plus S solid would give Fe S. So that's iron sulfide. So then if we know that 20 grams of iron are reacting with 32 grams of sulfur, we'll know that the product, which is also a solid, has an overall mass of 52 grams. This is because the charge is conserved as well as the mass is conserved.